Have you ever wished you could control things just by thinking about it, like in a sci-fi movie? Well, that future is a lot closer than you might think. Today, we're diving deep into the incredible world of brain-computer interfaces, or BCIs. This isn't just about cool gadgets. It's a technology that's completely changing what it means to be human. So grab your thinking caps, because we're about to explore how our minds are merging with machines. First up, what exactly is a brain-computer interface? Put simply, it's a direct communication pathway between your brain and an external device. No keyboards, no touchscreens, no voice commands. Just pure thought. It sounds like magic, but it's all down to the amazing science of our brains. Every time you think, feel, or move, your brain's neurons fire off tiny electrical signals. BCIs are designed to detect, analyze, and translate these signals into commands that a computer can understand. There are a few different ways to do this. The most dramatic are invasive BCIs, where tiny electrodes are surgically implanted directly into the brain. This gives the clearest, most precise signal. Think of it like having a direct line to the source. It's this type of BCI that has allowed people who are paralyzed to control robotic arms, type on a screen, and even regain a sense of touch. The precision is mind-blowing. Scientists can literally pinpoint the specific neurons associated with wanting to move your right hand, for example, and use that signal to move a cursor on a screen. But, of course, brain surgery isn't for everyone. That's where non-invasive BCIs come in. These are devices you can wear on your head, kind of like a high-tech swimming cap or a sleek headband. The most common type is an EEG, which uses sensors placed on the scalp to measure the brain's electrical activity. The signals are a bit noisier since they have to travel through your skull, but with the power of artificial intelligence and machine learning, we're getting incredibly good at decoding them. An AI algorithm can be trained to recognize the patterns in your brainwaves when you imagine clenching your fist or thinking of the color red. After some training, you could use these thoughts to fly a drone, play a video game, or even communicate. So, how does this decoding process actually work? It's a combination of neuroscience and powerful computation. Let's say you want to move a robotic arm. First, you'd imagine moving your own arm. The BCI records the flurry of neural activity this thought creates. At first, the computer has no idea what this jumble of signals means. But as you repeat the thought over and over, the machine learning algorithm starts to see a pattern. It learns to associate that specific pattern of brain activity with the intention to move. It's like teaching a dog a new trick, but instead of a dog, it's an incredibly smart computer. And instead of a treat, the reward is seeing the robotic arm move exactly as you intended. The more you practice, the more accurate and responsive the system becomes. It's a true partnership between the human mind and artificial intelligence. Now, let's talk about the real-world applications, because this is where things get truly exciting. The most profound impact of BCI technology is in healthcare. For individuals with paralysis, ALS, or stroke survivors, BCIs offer a chance to regain independence and communication. We've seen patients who haven't been able to speak or move for years use BCIs to type messages to their loved ones at speeds approaching normal conversation. It's not just about communication, it's about restoring connection and dignity. There are even BCI systems being developed to help restore vision to the blind by sending signals directly to the brain's visual cortex, or to help control tremors in patients with Parkinson's disease. Beyond healthcare, the possibilities are endless. In gaming, imagine playing a fantasy game where you can cast spells just by thinking about them. No controller needed. Companies are already developing BCI headsets for immersive virtual reality experiences that respond directly to your focus and emotional state. The game could get harder when you re-feeling confident or introduce a calming scene. If it detects you re-getting stressed, then there's the world of robotics and industry. A factory worker could control a swarm of robots with their thoughts, assembling complex products with a level of coordination that's impossible with manual controls. A surgeon could manipulate a microscopic robotic tool with unparalleled precision, all guided by their intentions. Even the military is exploring BCI technology, envisioning pilots who can fly advanced jets as if they were an extension of their own body, reacting at the speed of thought. This all sounds incredible, but it's important to pause and think about the other side of the coin. As we get better at reading minds, we have to ask some serious ethical questions. Who owns your brain data? Can your thoughts be hacked? A BCI that knows what you're thinking could be a goldmine for advertisers, or worse, for surveillance. If your thoughts can be used to control a weapon, what are the implications for accountability in warfare? And what does it mean for our identity if our brains are constantly connected to the cloud? Will we lose our sense of self? These aren't just philosophical questions anymore. They are practical challenges we need to solve as this technology develops. We need to build strong privacy protections and ethical guidelines right from the start to ensure that BCI technology is used to empower humanity, not control it. Another major challenge is accessibility. Right now, the most advanced BCIs are incredibly expensive and require specialized medical teams. How do we make sure this technology doesn't just create a new divide between the haves and the have-nots? The goal should be to make these life-changing tools available to everyone who needs them, not just the wealthy. So, what does the future hold? We're moving towards a world of seamless human-machine integration. The BCs of the future will likely be smaller, more powerful, and less invasive. Imagine a BCI that's as common as a smartphone, perhaps a discrete implant or a stylish wearable. We might be able to learn new skills just by downloading them into our brains, or communicate with each other telepathically through a brain-to-brain interface. This is the long-term vision of future where the boundaries between human intelligence and artificial intelligence begin to blur. It's a future that's both thrilling and a little intimidating. Brain-computer interfaces represent one of the most powerful technologies ever created. They have the potential to cure diseases, unlock new levels of creativity, and fundamentally expand human potential. From decoding neural signals with AI to controlling machines with our thoughts. We are at the very beginning of a new chapter in our evolution. The journey will be complex, filled with challenges and ethical dilemmas, but the promise of a better, more connected future is undeniable. We are literally witnessing the next step in the human story unfold. Thank you so much for joining me on this deep dive into the world of brain-computer interfaces. It's a topic that's going to become more and more important in the coming years. What are your thoughts on BCI technology? Are you excited? Or do you have concerns? Let me know in the comments below. And if you enjoyed this video and want to explore more cutting-edge science and tech, don't forget to like, subscribe, and hit that notification bell. Thanks for watching, and I'll see you in the next one.